Number 8 on topic 1 was one of those, it's not a really high percentage question, but it hasn't been asked in quite some time, and you are responsible for it. It is a rational inequality. And the answer here on the number line is everything from -7 to -4 inclusively, but it's open here. This is what the solution set looks like. A is in between -7 and -4. A lot of you are having trouble with these solution sets. These inclusive solution sets, the symbols are always in the same direction. The smaller number goes to the left, the larger number goes to the right. This part here is called set builder notation. It's optional, but if it does say in set builder notation, which it could, you do have to know to put that there. Notice the variable was A, so I put A's here. We have a habit of also wanting to put X all the time. You have to use the same variable. Now, this was the original problem here, and anything with an inequality symbol with one variable, the test feature is absolutely amazing. So you want to put this into Y1, and once you put that into Y1, you can get exactly what your shading looks like. Now, why did I circle this -4 right here? Because that's where this fraction happens to be undefined. And I show you here, I took the denominator, set it equal to 0, and -4 is what A is going to be equal to there. That can never be part of our solution set, so we want to keep it open. After we do that, we want to pretend that this inequality symbol is an equal sign and solve this as if it were a proportion by putting that 3/1. It's actually a simple, like 7th or 8th grade question, this proportion. Cross multiply, and we get A is equal to -7 after we distribute and divide by the appropriate, the 2. So -7 is our other boundary value. So we go back to our number line, I actually wrote it over here, and you put your -7 in. Now, why did I make this open as well? Because the original symbol was an open symbol. It was a greater than symbol. If this symbol were greater than or equal to, the -7 would have been filled in. The -4 still would have been open because that's where the graph is undefined. Now, how do I know to shade? Back in the day, we used to go through all of these intervals, 1, 2, 3 intervals, pick a test point there like -8, -6, 0, and check to see if it worked in the original. And if it checked, you shaded there. If it didn't, you didn't shade. Now, we have the graphing calculator now. So this is our graphing calculator, and I type this into Y1. I get my greater than symbol in my test menu by doing second test, right? And now that I have it typed into Y1, I do a zoom 6. It's actually going to show me the graph and where to shade it. You can even double check. This says 1, 2, 3, 4. That's -4, 5, 6, -7. So I do have the boundaries correct. That's the only place to shade. So again, after we're done with the shading, if they want a graphical solution, we give them a number line. If they want a solution set, this is the solution set.